A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, and the annotations shall be made available as soon as possible. Only when there is a technical issue is it getting delayed. But I hope the delay is not persistent. So, hello, good evening to all of you, and welcome to Baiju's Exam Prep IS. Welcome to the session of climatology, where we proceed ahead with our discussions where we left off on Saturday. So, basically, on Saturday, we looked at some of the very important and key areas for examination. For example, we looked at what do we understand by a Walker circulation. Then, for example, we looked at the entire aspect of the Enzo phenomena. What is it that an El Nino is? What is the condition of a La Nina? What is the condition during the normal Walker circulation? When is it that Australia will receive rainfall? When is it that South America will receive rainfall? Then we also moved and looked ahead into the area, for example, of Indian Ocean dipole. That Indian Ocean dipole also has an influence over Indian climate, where we observed what is the normal case of an Indian Ocean dipole, where the eastern portion of the Indian Ocean, in comparison, equatorial Indian Ocean, eastern portion of it is comparatively warmer as compared to the western portion of the Indian Ocean. Now, that can basically accelerate or accentuate to form a negative IOD. Neutral and negative IOD, they are detrimental for Indian monsoon, disadvantageous for Indian monsoon. And a positive Indian Ocean dipole is beneficial or advantageous for the Indian monsoon. In all the meanwhile, we have also been taking a look into under what conditions are there chances that a tropical cyclone is more likely to be formed in the region of Bay of Bengal or in the region of Arabian Sea. So, what is the chances or the process of observing that or looking at the creation and the formation of that? Then we observed the presence of a moving pressure cell across the entirety of the planet in the equatorial and more or less the tropical region, but more precisely around the region of equator, and that is the MJO or the Madden-Julian oscillation. Now we observed that whenever you have the enhanced rainfall phase of the MJO, it tends to bring higher than normal amount of rainfall. Whenever you have a suppressed phase of MJO, that is when you will have dry conditions. So when the enhanced phase of MJO will be present over the Indian Ocean, then that is beneficial for India during the monsoons. We also looked at the cycle of that MJO. If it has got a shorter cycle, it is always advantageous for Indian monsoon. If it takes a longer period of time to repeat itself, it is detrimental for the Indian monsoon. We took a look at the few of the previous year questions framed from this area as well. Now, all of this shall be brought into application today when we study the portions of Indian monsoon. But before that, this is one of the portions of jet streams which we are going to complete. And then after that, when we move over to the portion of Indian monsoon, your analysis and understanding of the Indian Ocean dipole, of the Enzo cycles, of the MJO, and even for this jet stream, that shall be applicable in the portion of the Indian monsoon. So today, we shall initiate from the portion of jet streams, and then we shall be moving ahead into the portion of Indian monsoon. Okay. Now, in 2024, El Nino will be strong. So, what if a positive IOD is formed? So it will, see, in that case, it will compensate the loss of rainfall. It is not as if India will receive excessive amount of rainfall, but in that case, it won't be the situation where India will be deficient in the amount of rainfall. Okay. And Biswajit, as of now, the plans are not afoot for that. So, as of now, at least in the near term future, that is the schedule does not allow it. So that is the case. Okay. So yeah. So now we come to the portion of the jet streams. Yes, Prem Kumar, a positive IOD can neutralize the impact of El Nino on India, not across the rest of the world, only on India. Okay. Brajneet, is there any chance to continuously will El Nino occur? El Nino can repeat itself for a couple of years. Yes. For example, 2023 was a year of a weak El Nino, and 2024 is one of those years where El Nino is supposed to get stronger. It is expected to be much more stronger. Can MJO have some effect with La Nina? So MJO, basically the relation with MJO and whether it can create La Nina conditions or El Nino conditions or not, that is still something which is being read about, which is being studied about. And as we speak, basically you have the Indian research institutes along with the US research institutes. They are carrying out a detailed study in order to understand whether the MJO can influence La Nina, El Nino conditions or not. Okay. Radhika, jet stream is not clear. Which portion of jet stream is not clear, my dear friend? Please let me know, because till now we have not even started the discussion of jet stream. So if it is not clear, if even now, so there must be a particular issue. Sushmit, why do we see wave pattern in front like occluded front? That is basically, the wave pattern is generated because in certain areas the warm air comes into the region of the cold air. In certain areas the cold air enters into the region of the warm air. That is why you have a wave pattern generation. So Radhika, please let me know which portion of jet stream is not clear so that we can move ahead. So nonetheless, till you find or frame the question, let us initiate the discussion about jet streams. Now, what are these jet streams? And basically, the discovery of this jet stream is something which happened accidentally in the 20s. In the 1920s, you actually had a climatologist who released, or who was basically performing a balloon experiment. Balloon experiments are where you attach certain sensors to a balloon, and that light air raises that balloon higher up into the atmosphere. And basically, with the help of the sensors, he was able to measure, he was able to detect the movement of very fast velocity winds in the upper region of troposphere. That is something that he was able to detect. Now, how these winds would behave, where these winds would be in existence, that is something which was not very apparently clear at that point of time. Further researches were not carried out, and the issue basically died down. Then, then came the Second World War. Now, during the Second World War, what happened was that US was involved in a direct conflict with Japan, where the US fighter bombers were given a mission, given a task to basically carry out the bombing missions after crossing the entirety of the Pacific, bomb the region of Japan, and then come back after crossing again the entirety of the Pacific. So it was a long journey. Now, while carrying out these missions, the US fighters, they experienced something unique. They basically found out that there's a pattern. As these would go towards Japan, as these fighter planes would go towards Japan, that would be a direction from east to west. Now, during that motion, they would experience very strong winds in the upper troposphere, which would reduce the speed of their aircraft. And then, after bombing Japan while coming back, they would experience that the winds had enough potential to accelerate the speed of their aircraft. And they consistently noticed it, that when they would go from east to west, their speeds would reduce. When they would come back from west to east, their speeds would substantially increase. Now, they reported it to the air headquarters. All the air headquarters basically have very acclaimed climatologists in order to have that forecasting system. Now, the air headquarters basically reported that something very similar is also being experienced by the pilots over Europe, where when they are moving from west to east, their speed increases, and when they are moving from east to west, their speed decreases. So everybody knew that there is a very strong wind system in the upper region of troposphere that moves in a direction of west to east. And because this was a very fast moving air or a very fast moving air column, that is why they would name it as a jet stream. It would influence the speed of the jet aircrafts. So that is why they would name it as the jet stream. So from that, the name jet stream was derived at. Ever since that chance discovery, there have been various different works, various different processes in order to understand these jet streams better. Now we know substantial amount of information about these jet streams, but still there are large areas which are unknown. But nonetheless, we at least know this particular feature, that these jet streams, they move in a direction of east to west, or rather they move in a direction of west to east, both in the northern as well as in the southern hemisphere. They move in a direction of west to east. And these are very fast bands of winds in the upper troposphere. Now, these jet streams, by the way, they are also referred to as geostrophic winds. Geostrophic winds. Now, geostrophic winds, these are those kind of winds which in a way move parallel to the latitudes. That is what the nature is. So such kind of winds are referred to as geostrophic winds. So these tend to move parallel to the latitudes. So here we will study the basics of these jet streams, and if you are open for it, we'll also take a look at the formation of these jet streams. Why is it that these jet streams, they get created in the first place? That is something that generally you don't encounter while studying the books or while reading the books. But again, that is purely up to your level of interest. If you want to know, that is something we'll get into. But if you are happy just knowing that what these jet streams are, that also will be sufficient for your general studies requirement. Now, when I say basically these jet streams, what are they? They are basically relatively narrow bands of very strong wind in the upper levels of atmosphere. Here, by upper levels of atmosphere, we refer to the upper regions of troposphere. Okay, upper regions of troposphere. In the upper regions of troposphere, you have this very strong movement of wind. The winds blow in a general direction from west to east, and the flow often shifts north to south. What does this mean? This basically tells you about the fact that as you talk about these jet streams, or when you talk about these jet streams, let's suppose this is the planet. Now, if you have a jet stream which is going to move like this, now its general direction of motion is same as that direction of motion of the planet from west to east. Okay, from west to east. But this jet stream in itself, the positioning of it can shift north or can shift south. Sometimes this jet stream can be present here. Sometimes that jet stream can come here also. That tells you what? That there has to be a seasonal variation. Anything which tends to move north or south, that means it is dependent upon the differential rate of heating and cooling in between different seasons. So invariably, as we will see, this is associated with the tricellular model of circulation. Have we managed to finally find out some time in our busy life so that we can revise the tricellular model of circulation? Have we managed to revise the tricellular model of circulation? Yes, I hope so. Because it has been a long time now. And I hope the dynamic pressure, the thermal pressure, etc., everything that is crystal clear. Because that will be of immense help immediately in the following module in the portion of Indian geography also. Okay. Now, then these jet streams travel in the region around tropopause, the area between troposphere and stratosphere. But it is not always going to be at the region of tropopause. If you have to take a kind of a side view where these jet streams move, so let's suppose this is the ground surface, you'll find the jet streams to be moving somewhat like this, where in certain areas the height would reduce maybe to around 6 to 8 kilometers from the ground surface. In certain areas, this can even increase to 12 to 15 kilometers from the ground surface. So there is that variation in height as well. Now, if I were to ask you, or if I were to talk about why this jet stream gets created, why is there going to be a formation of jet stream? Let us try to understand that. Process of formation. Now, this formation of jet stream is purely because of the difference of temperature in the air at an upper altitude. The difference in temperature in the air parcels at a greater height around the region of tropopause, in the higher end of the troposphere, that is responsible for the generation. So, difference of temperature in the air passes or in the air parcels higher up in troposphere. Now, how is it that this difference of temperature is going to initiate the movement or the existence of the jet stream? Let us try to understand and listen to this carefully. Again, something not to be found in the books. So that is why this is a concept, again, optional for you. So let us consider two columns of air. Let us consider warm air and let us consider cold air. Now we do know warm air has got a greater volume. We do know that cold air has got lesser amount of volume. I hope this color is visible, or let's go for this color. Let's assume this is your cold air and this is your warm air. And this is warm air. Now, let us also consider this portion. Now, at the ground surface, let's consider A, let's consider B. Which is going to indicate a high pressure, A or B, at the ground surface? No doubt in that. Always colder air will have a higher pressure. Colder air will have more dense molecules. So colder air will always have higher pressure. So this A at the ground surface will indicate high pressure. This B will represent near the ground surface a low pressure. So on the ground surface, wind movement is more likely to be from A to B, isn't it? So on the ground surface, wind movement is going to be from A to B. Now let's consider this portion. Let's name this as A dash. Let's name this as B dash at an altitude. Now look at the air parcels above that region of A dash and B dash. If I were to ask you about the pressure experienced at A dash or B dash, that pressure will basically be the weight of the air above A dash and B dash. That is going to exert the pressure. So out of A dash and B dash, which is going to indicate a high pressure here? Very good. Beautiful. Almost everybody is correct here. High pressure. So high pressure in this case is going to be above B dash, isn't it? Because you have more amount of air on top of it. Above A, you have negligible, almost negligible amount of air. So B dash is going to represent high pressure. A dash is going to represent low pressure. Observe that as compared to the ground surface, this is a reversal. As compared to the ground surface, the conditions above are something very different. So in the upper air also, can we say that between A dash and B dash, there's a difference of pressure? Pressure gradient force will be in existence, isn't it? So between A dash and B dash, and B dash, pressure gradient exists. Now, greater the difference of temperature, greater will be the pressure gradient. So here the winds will try to move from where to where? From B dash to A dash. That will be the general direction of the wind motion here. Winds always blow from a high to a low. Okay, Radhika, you had a question why winds are moving from A to B. Winds will always blow from a high pressure to a low pressure. So here, B dash to A dash will be the direction of wind motion. Now, this is happening at an upper atmosphere. So, frictional force, will the frictional force be high or will the frictional force be close to zero? In the case of the winds moving from B dash to A dash, the frictional force, will it be high or will it be close to zero? Why Santosh, Vishal, Lishi, and Athia and Shelja? Why? I want the reason. Why will it be high? Or is it the case that you had two options? So, frictional force. Frictional force, what is frictional force? Frictional force is the force of resistance which is offered. Okay, frictional force is the force of resistance which is offered to the wind. So where is it that the winds will basically experience greater amount of resistance? Closer to the ground surface or higher up? We have seen that closer to the ground surface, you have trees, objects, mountains, plateaus, etc., which will basically reduce the speed of the wind. But when you go at an elevation of 1 to 2, 3 kilometers, above that, the resistance is very less. So the air moves with a greater speed, isn't it? So higher in the higher altitude, always the frictional force will be close to zero. Okay. Revision has not happened in this. Anyways, so here, basically, the frictional force is close to zero. So the wind speed is very high. Okay. So this wind speed is going to be very high. Is very high due to less force of friction. Okay. Why the column of cold air is shorter? We have already seen that the volume of cold air is less than the volume of warm air throughout the previous sessions. Haven't we drawn a diagram like this? Haven't we continuously drawn a diagram like this, that you have warm air, you have cold air? In cold air, you have the particles which are much closer to each other because there is less amount of energy. That is why the particles slump together. That is why they have lesser volume. Have you not studied that? So that is why cold air will always have a lesser volume. But jet stream increases from west to east. Yes, so jet stream increases from west to east. Jet stream moves from east to east, west to east. Anyways, so kindly pay attention. So here, between B dash to A dash, there will be movement of wind with a very significant amount of force, very strong speed. The wind will be moving. Now, we have seen about or read about the Coriolis force also. Coriolis force, if let's suppose the speed of the wind is high, Coriolis force, will it be lower or will it be higher if the speed of wind is high? Coriolis force will be lower or will the Coriolis force be higher? Okay. Coriolis force is always higher. Faster the speed of the wind, more is the amount of Coriolis force. So more amount of bending. So higher Coriolis force leading to more bending. So that means we can come to a conclusion that in the upper atmosphere, from the region of warm air to the region of cold air, there's a very strong movement of wind. In the upper atmosphere, the winds move from regions of warm air air to regions of cold air. Okay? Now, let us consider the case of the planet and let us understand how this movement would look like. Let's suppose we consider the planet here. Now, in the upper atmosphere, near the tropics, you will have warmer air as compared to the temperate regions. So here, let's suppose you have warm, here you have cooler air, and here you have cold. So from warm to cooler, the air will try to move, but there is bending to the right. So the air will move like this. Here again, the air will try to move, but it will bend to the right. So like that, you have an entire motion in this direction. Now, what is this direction? Overall, when looked at across the entirety of the planet, it is a direction of west to east. Now, again, in the upper atmosphere, think about it. Polar air is going to be very cold as compared to the temperate region. So, here, from warm to cold, again, that deviation to the right. Again, that deviation to the right. So, that is how you have the movement of winds from the west direction to the east direction. I'll come back again to this slide. Let us cover a bit more of it. I'll bring you back again to this particular portion of the PPT. Coming to, let this sink in, let this digest for some time. Ankush, Coriolis force will have no effect upper atmosphere, sir. On Sunday, you told this is not, sir. First of all, Sunday we did not have any interaction, Ankush, and we did not have class on a Sunday. But when is it that, or in which context have I told you about the portion of mesosphere, or in that area, or in which portion do have you got that kind of an information from? Also, it depends on the context of the question. Trade winds. So I told you trade winds are surface winds. So surface winds will experience Coriolis force. In the Hadley cell, the upper portion of the portion going against the trade winds in the upper atmosphere, they will also experience Coriolis force. That is why they will have a sinking at 30° north. Kindly take a look at the recordings. Which particular question was it? Bring me to light. And then, so basically, the shape and the size of jet streams. Jet streams basically move as winds or bands of very strong wind movement. That is the movement of the jet streams. It will appear like a river of air moving in upper atmosphere. Rivers of air moving in upper atmosphere. That is what the appearance will look like. Now, these particular jet streams, overall, as they move, they will have very high speed sometimes ranging up to the level of 400 kilometer per hour. Sometimes on an average around 200 to 50 plus 300 kilometer per hour. Now here also, when you move these jet streams, when you observe the movement of these jet streams rather, here, just like the case of the river movement, in the case of the river movement, what is it that we had seen? If let's suppose this is the river, fastest speed will be at the central portion. So here also, speed at the central portion is the highest. Central portion is the highest. Okay. Now here, where is it that this formation will happen? In which part of the planet will we experience this formation? Wherever there is a difference in temperature in the upper atmosphere, right? So wherever there is difference in temperature in upper atmosphere. Now that difference in temperature will create a pressure gradient force. A pressure gradient force in upper atmosphere. That pressure gradient force created in the upper atmosphere, that basically leads to the movement of winds with very high speed. So, because of thermal conditions in the upper atmosphere, you will experience the formation of these jet streams. So, jet streams, they are stronger in winter in the northern and the southern hemisphere because that's when air temperature differences that drive them, they tend to be stronger. Now, the actual appearance of jet streams results from the complex interaction between location of high and low pressure systems, warm and cold air, and also the various seasonal changes. They meander around the globe, moving or having a variation in terms of height associated. Now, where is it that this difference in temperature really comes into existence? So, let's consider the tricellular model of circulation. As per the tricellular model of circulation at 0 degree, at 30 degree north, 60 degree north, and at 90 degree. So here, the air will rise up. It rises up here, diverges, moves here, comes down. One portion goes here, other portion goes here. It interacts with the cold polar winds. These rise up. This is the tricellular model of circulation. Now, in the upper atmosphere, where will we experience a significant difference in temperature? Will we experience a difference in temperature here? Will we experience a difference of temperature in the air parcels here? If no, why? If yes, why? Meanwhile, I asked you in La Nina when warm winds returning from Australia, warm winds returning from Australia to Peru, then why trade winds will not affect the wind? So you said it is, so it's affected by in the upper atmosphere. So you might have asked about the Walker cell. In the Walker cell, they are moving the Ankush, they are moving parallel to the equator. So when you have anything which is moving parallel to equator in the upper atmosphere, that will not get impacted by the Coriolis force. But anyways, La Nina doesn't have war wind returning from Australia to Peru. So I don't know. Anyways, winds are creating low pressure. No, because of divergence. No, because tropical regions near equator. No, it is minimum difference of temperature. Sushmit, Shahid, Krishika, you are correct. Vikalp, incorrect. Sakshi, this has got nothing to do with the portion of the high pressure or sinking winds because both the sir is same. Which both sir is same? Both the winds, you mean? Okay. I thought you were seeing some parallel individual along with me. Because of divergence, as moving apart, tropics heated by vertical insolation, because in 0 degree temperature is similar. Okay. So most of you are correct. The final answer to this will be that in the upper atmosphere above ITCZ or above equator, you will not have a difference of temperature. The reason being very simple, that if you consider which are the winds which are going on top of the ITCZ, both these winds are coming from the tropics. Both the winds are coming from the tropics. Now, the winds from the tropics, it is not to say that they will have the exact same temperature. There might be a temperature difference of 1 or 2 degrees Celsius between the northern tropics and the southern tropics. But by the time that they rise up and by the time that they reach an elevation, there, these similar winds having similar properties, they will not indicate a difference in temperature. Now, if I ask you here, will there be a difference in temperature in this portion, yes or no? If yes, why? If no, why? Okay. Yes. Correct. Good. Here, basically, the difference in temperature will be very accentuated, very high. Why? Because one of the winds is coming from the region of the tropics, the other wind is a polar wind. So the difference of temperature between the tropical wind and the polar wind will always be quite significant. So here you will have a significant or a substantial difference in temperature. Warmer air on this side, here you will have colder air. Right. Now what about this one? In this region, above the subtropical high pressure, will there be a difference in temperature? Yes or no? Again, good. The answer is yes. There will be a difference in temperature because here one wind is coming from the region around equator in the upper atmosphere. Another is coming from the region around 60 degrees. So it will not be that high a temperature difference as experienced in the around 60 degrees, but still there will be a difference. So in these areas where you have a difference of temperature, you will have the existence of these jet streams. Now, will this be is this a phenomena which will be present only in the northern hemisphere, or is it a phenomena that you will experience in the southern hemisphere also? So is it something which you will experience only in northern hemisphere or in both the hemispheres? In both the hemispheres, isn't it? This was a question that UPSC asked in the prelims last year, right? So obviously it is associated with the pressure cells, the pressure belt. So they will be present in the southern hemisphere also. Now these jet streams, they will basically be associated with these pressure cells. We do know that with the change of the seasons, with the variation of the seasons, the pressure belts, they tend to shift to the north and to the south, isn't it? So let's suppose this subtropical high pressure belt has shifted slightly to the south. So this jet stream, the subtropical jet stream, will also tend to be dragged slightly to the south. It will come somewhere here. Sometimes it can shift to the north also. So that is why you will observe that the jet streams tend to move from south to north. That variation, or they don't tend to move from south to north, they move from west to east. But these jet streams have a variation. They tend to shift, rather, they tend to shift to south and north. As they are moving from west to east, they tend to shift from south to north with the changing of the pressure belts that happens between the various different seasons. We have seen that the ITCZ in itself shifts and the various pressure belts also shift accordingly. Now, what is the direction of motion? So again, let us concentrate upon this particular portion about the direction. So here, let us consider the planet. Now, you have, let's assume this is the region of equator. So you have got the region of warm air in the upper atmosphere here, warm. You have cooler air, and you have very cold air. Here also warm, cooler air, and then very cold air. So let's first of all say or think about the southern hemisphere. In the southern hemisphere, winds will, in the upper atmosphere, as we have seen with the formation of the jet stream, they will move from warm to cooler region in the upper atmosphere, isn't it? Now, here in the southern hemisphere, due to Coriolis force, they will bend to the left. So, the leftward bending is in this direction. Again, let's suppose the wind is trying to move, it will bend to the left. So, like that, the wind tends to move after bending in the leftward direction. The winds will tend to move in this direction because overall they have bent to the left. Now, this is a direction of motion. From where to where? From west to east. Again, from cooler, and from here you have the cold polar wind. So again, the wind motion will be from here to here, but they will bend to the left. So again, the entirety of the portion or the entirety of the motion will be like this, west to east. In the northern hemisphere, wind motion will be somewhat like this. This time it will bend to the right. So bending to the right is in this direction, like this, it will move. Like this, it will move. Isn't it? So that means in between the areas of the Hadley and the Ferrel cell, as well as in the upper region, the area between the Ferrel and the polar cell, you will have the formation of these jet streams. Why these jet streams are created, I hope we know now. Why that formation happens, why do they move from west to east, and why do they shift from north to south. I hope this portion is understood. Yes? Yes, Amritansh, correct. Lishi, which jet stream would be stronger? The one where the temperature difference is very high, that is the polar jet. So this entire process of formation is understood by everyone? Good. Now, when we talk about these jet streams, they have a kind of a meander, that is a wavy path. Now, they have both horizontal and vertical meandering in place. Again, both horizontal and vertical meandering in place. And this time, I want the reason from you. So let me elaborate this entire problem statement. And then I want the reason from you that why there is that vertical and horizontal meandering. So vertical meandering is the first of all, the horizontal meandering is what you are seeing here, right? Between different latitudes, the movement of these winds is happening. That is a kind of a horizontal meandering. Vertical meandering is what I had shown you, that in certain areas, the jet stream dips, in certain areas, it moves up. So in certain areas, the height will be 12 to 15 kilometers. In certain areas, it will be 6 to 8 kilometers. So, first of all, why is it that these tend to move in that wavy pattern in between different latitudes? What is the reason for that horizontal meander? due to heating of landmass and oceans at different rates, water bodies, distribution of land, difference in temperature, shift of pressure belt, temperature difference. Okay, most of you are more or less approaching the correct answer, and most of you are talking about the different rate of heating of land and water. But even over the land mass, you will find this meandering. Even over the complete water bodies, you will find this meandering to happen. The reason for that horizontal meandering is very simple. When we took a look at the air masses, we observed that in certain areas, the warmer air masses, they moved to the region of the cold air. We observed that in certain areas, the colder air moved into the region of the warm air. So that interaction between the warm and the cold air, that does not follow a straight line. So if that does not follow a straight line and rather follows a wave pattern, then in the upper atmosphere, the winds which will be generated will also follow a wave pattern, right? So the extent of the cold and the warm air mass, that tends to happen in each other's territory. That is why you will have that kind of a meandering, horizontal meandering. Okay, I hope that is understood. That in certain areas you have the warmer air moving further, in certain areas the colder air comes further. So that is why you will have, wherever you have that difference of temperature, there you will have this jet stream. Now, what about the vertical? This vertical meandering. Why is it that this vertical meandering will happen? Troposphere size. Okay, that is almost correct. Insolation. Vibhu, very good. Because of physical barriers? No. It is basically because we do know that air masses of different temperature will have variation in height. We do know that warmer air mass will be much more expansive, colder air mass will be much more shorter. So that is why it is not in every place. Let's suppose you are over India. Now, the extent of the warm air mass or the temperature of the warm air mass can be very different from the temperature of the warm air mass in Iran, let's suppose. Right? The temperature of the cold air mass over Iran and the temperature of cold air mass to the north of India might be very different. So that is why, because the height of these air masses are different, that is why you have a vertical variation. Okay? So this is where you have, I hope you are understanding the horizontal and vertical aspect. I hope that portion is not confused. This is a vertical variation in height. Vertical variation in height. This is the horizontal waving or variation in terms of movement. Now, if you take a look at this image represents this jet stream. Now, obviously, you can imagine the movement of a jet stream in a three-dimensional manner to be something of a very unique kind. Where let's suppose, if you consider that movement, it will be, first of all, dipping and moving up, but it will also come forward, bend back again, again come forward, again bend back. So there will be that vertical variation and that horizontal variation associated as well. So that kind of a motion associated is going to be linked with the jet stream. Now, we have seen that these jet streams, they are created due to the pressure belts, right? Almost closer to the pressure belts is where you will have these jet streams to be created. So these jet streams are just like the wind systems, they are classified into the permanent wind systems and the temporary winds. These jets also have got a classification into the permanent jets as well as the temporary jets. So Earth has got four primary or the permanent jet streams. So here, which are those in both the hemispheres? You have the polar jet, which is very strong. And then you have the subtropical jet. It is also known as a subtropical westerly jet because it moves from west to east, right? In the subtropical areas. So two in each hemispheres, both in northern and southern hemisphere. Okay. Now here you also have some temporary jet streams which come into existence during certain seasons for a very short time duration, and that too in a small area, not across the entirety of the planet. Just like you have the local wind systems, here also you have the concept of a temporary jet. Temporary jet in a small area or in a limited region, and that too for a small duration. So here, if you take a look at for some of the examples, we will study one of them in the next module immediately with regards to Indian monsoon as well. So, for example, you have the tropical easterly jet, tropical easterly jet. You have the case of the Siberian jet or the Somali jet, first of all, the Siberian jet, and so on. These are your temporary jet streams, very temporary duration in a small area. For example, Somali jet moves in the during the time of the Indian monsoon, sometimes, not always. They move in a direction from the region of Somalia over to the Indian mainland. So that is a direction southwest to northeast. Tropical easterly jet, it moves in the upper atmosphere from the region, upper atmosphere, not along the surface. In the upper atmosphere, it moves from above the region of Tibet, that is where it originates. It moves across the entirety of the Indian subcontinent, crosses equator, sinks into the region of mascarene high pressure in the southern hemisphere. So that upper movement, that is the tropical easterly jet. I'll tell you more about this tropical easterly jet in the portion, its formation, its existence in the portion of Indian monsoon. So that is the case of these jets. Now here, this is a kind of a satellite image of the jet streams. Now, here I want you to take a look into this jet stream and try to assimilate something greater. First of all, here you will observe that when it comes to very high barriers, physical barriers, such as the Himalayan ranges, the Himalayan mountain ranges, they are very, very high, isn't it? The Himalayan mountain ranges, for example, the Great Himalayas or Himadri, the average height is around 6 kilometers. In certain areas, even 7 kilometers, 8 kilometers from the sea surface. So that is where these jet streams, they will get interrupted because their lowest height will be around 6 to 8 kilometers in certain areas. So observe how this subtropical westerly jet, that gets bifurcated into a distinct northern branch of the jet and a distinct southern branch which passes through the region of India. So it gets divided into a distinct northern branch and a distinct southern branch as well. Okay, that is where it gets divided into. Now, imagine what happens during the seasonal variation. Let's suppose it is the winter season. During the winter season, as all the various different pressure belts they shift slightly to the south, even this subtropical westerly jet will slightly shift to the south. Now here, as it is shifting to the south, its northern branch gets weaker and weaker, whereas the southern branch keeps on getting stronger and stronger. Then, during the summer season, this entire jet stream with the shifting of the pressure belts shifts to the north. And when that happens, the northern branch gets strengthened. The southern branch weakens and eventually disappears. But nonetheless, these jet streams, they are not able to move through physical barriers such as the Himalayas very easily. Okay? Now, after that, another concept about how these jet streams impact the weather phenomena. So basically, these jet streams, they act as a carrier of weather systems. They feed the various weather systems, they transport the weather systems. And when I say transport the weather system, let's suppose in any area you have a distinct low pressure, a very distinct low pressure. Now, think about it carefully for a brief moment. Apply your logic. I hope till now oversaturation has not happened. Is the mind still open, or have we reached that point of saturation where everything has started bouncing up already? Are we comfortable, guys? Or is there any point of concern up till now? All good, alive, kicking, right? Horizontal movement not understood. See, I knew that there is something going on. Yeah, being alive is the best thing. You should not have any complaint after that. Horizontal movement. As in, why is it that horizontal meandering is happening, Anjan? Or why is it that the winds are moving horizontally? Which was the portion not understood? Physical barriers not understood. Okay. So it's, if suppose you have the Himalayan mountains like this, very high, these jet streams, when they dip and then they rise up. So in this case, will they be able to move through the region of these mountain chains? No. So that is why what we have seen earlier in the situation is that as they encounter, this is the region of the Himalayas. I hope that in this map it is clear. This is the region of the Himalayas. So rather than climbing over the Himalayas and then going, it simply becomes discontinuous. It divides itself into a distinct northern and the southern branch. So here, when we talk about the physical barriers in the form of Himalayas, the subtropical westerly jet is unable to move on top of the Himalayas. So that subtropical westerly jet is unable to move on top of the Himalayas. So the jet stream bifurcates into a distinct northern and southern branch as they cross the region to the west of Iran and Afghanistan. Is that understood now, Githyon? What is the average speed of the jet stream? Average speed of the jet stream is around roughly 250 to 350 kilometer per hour. Anjan, you have not understood the horizontal meandering. So Anjan, basically, if you recall the discussion for the air masses, we have had a discussion earlier. I don't know if you were present there, but I think you were. Basically, when we talk about the planet, we do know that in certain areas, the warmer air in certain areas will have an extent up till here. The warm air mass in certain areas will have an extent northwards also. And in certain regions, it is the colder air which will come southwards, colder air which will move to the south, isn't it? So, where is the jet stream created? Jet stream is created wherever there you have the variation in the temperature in the upper atmosphere. So, the region of the creation of the jet stream will follow this boundary system. Now, if I remove everything from here, let's suppose I remove all the things that I have drawn here, just the path of the jet stream. Will you be able to see a kind of a wavy pattern for the existence for the movement of this jet stream? Are you able to observe a kind of a wavy pattern, excuse me, of this jet stream? So that is purely because in certain areas, the colder air comes further southwards. In certain areas, the warmer air goes further northwards. Is that understood, Anjan? How could it move to east side? It should bend towards the left in the southern part. I was actually surprised that why no one has got a doubt over that. So for a brief moment, I said to myself that maybe this is one of those things that everyone in this batch has understood in one go. So I was still pinching myself why this question has not come. Okay, I'll come to it, Piyu. Why are not jet streams on over the top of it? Over which top of it, Vikal? So, Piyu, if I talk about, let's suppose, movement of wind like this, which is left? This one is left, or if I name this 1 or 2, which is going to be the left of this wind? 1 or 2? Hmm. See, this is where the weak portion is. I asked you which is left, and Girish, you are saying both are left. How can both be the answer, my dear friend? Many of you try to play it safe during the answer so that I don't ask you, point a question and ask you. How do you decide what is left or right? Is it a random guess? So basically, always take a look at the direction from where it is originating. Put yourself in that region, look into the direction of movement. Your leftward side will be the leftward direction. Your rightward side will be the rightward direction. So if you put yourself here, look into this direction, right? This will be your leftward movement. This will be the rightward movement. So here, as the winds move, this will be the leftward movement. So they are deviating to the left, isn't it? Okay. So is that understood? Okay. Now, can we move ahead? Any further doubts? Substantial amount of doubts? I meant the air masses will not have jet streams on top of it. Generally, air masses will not have so much height. How much height? See, In the tricellular model of circulation, Vikalp, we have seen that there is a movement of the air mass. The air mass is what? Parcels of air. So you have at 60 degrees the air, polar air, and the tropical air coming, converging, rising up. Mostly the warm air will rise up, some amount of cold air will also rise up. So there is that distinct gap between the air mass on the ground surface typically and that rising air. Overall, if you consider that entire region, there will be a variation in terms of the air column. Warmer air column always will have a greater height. The colder air column will always have a shorter height. That is why that vertical meandering. Okay. Now, then we come to the jet streams and basically how they help carry the weather systems from one region to another. Now, when we talk about jet streams and the weather, this is where it gets very complicated. So I'm not going to delve into the very significant complexities. Already, I feel that in up till this portion itself, many of you got zoned out. So jet streams and weather. So understand, guys, this is as much detail as you would want in any question associated with jet stream. Once you are comfortable with the portions of the PPT, you are not required to study through any book. This PPT would be much more than sufficient for your entire requirement of the GS as far as these areas are concerned. Okay, so restrict yourself to the PPT and ARMs, repeat them again and again, try to internalize. The more revision, the better. Now, here, let's suppose on the ground surface, you have a low pressure. Okay, wind is rising around that low pressure, and the wind has to diverge. Now, if I make a statement that as long as this upper air divergence is maintained, the low pressure system will be maintained. Will that be a correct statement or incorrect statement? As long as the upper air divergence is maintained, the low pressure system will be maintained. Correct or incorrect? Very good. It will be correct. Why? Because when there is that divergence in the upper air, it is basically evacuating the winds from this area. It is carrying away the winds from this area. As it is parting away or carrying away the winds, means more vacancy is created, more winds can rise up, more winds will rise up. Eventually, more winds will be evacuated, other more set of winds will rise up. So it will be a continuous process, right? So that is where many of the times what happens, let's suppose there is a jet stream movement somewhat like this in this direction. Now, can I say that if there is a jet stream moving over this area, it will accelerate the upper air divergence? Isn't it? I can say that it will keep on carrying away the air away from this region of divergence. So if there is a jet stream in this region, this low pressure system will further get accelerated. Maybe if this low pressure system had led to the formation of clouds, if let's suppose the low pressure system had led to the formation of clouds, if the jet streams move through, they have the ability to carry clouds from one area to another, isn't it? Let's suppose the jet streams, as they are moving horizontally or vertically, as they come across these clouded regions, they have the ability to carry them through, right? So that is why jet streams become a carrier of weather systems. Earlier, you might have received rainfall in this area. Now, you might end up receiving rainfall in this region altogether because the jet stream has carried over the weather system. Having said that, when we talk about jet streams, understand these are bands of very fast moving air. a large band of very fast moving air. That is what a jet stream is. Now, these jet streams, they are also created due to the air column underneath them. So if I were to simplify what I have said with the help of a diagram, I can make a diagram about a jet stream like this, the cross-sectional view of the jet stream. This is your jet. Now, this has purely been created because of difference of temperature and pressure in between the air masses here. Fair enough? Now, a jet stream is not a small phenomena. That over Indore you will have a jet stream, over Bhopal jet stream is not there. Again, over Ujjain jet stream is there. Again, by the time that you go to Raipur, jet stream has disappeared. It is not going to be like that. We have seen earlier also, they can continue for hundreds and thousands of kilometers. Observe here, they are continuing for hundreds and thousands of kilometers, isn't it? Now, this jet stream does not allow mixture of winds from one side to the other underneath them. It does not allow the movement of wind systems underneath them. Why? That is because these jets, they are formed because of these air columns. These air columns, they are almost static in that area. Unless and until the entire jet tends to move, these air columns here, they will be almost static. If the entire jet moves, maybe air can come up till here or can retreat. So the jet doesn't allow jet streams, do not allow for mixing of air from one side to the other, which means, or the simplification of this is, colder air from one side is not allowed to come into the region of warm air and vice versa. So in a way, we can also say that these jets, they serve as an obstruction for the latitudinal movement of the winds from one latitude to another. The winds won't be able to move if you have the jet stream in existence over there. From south to north or north to south, the movement of the winds will be interrupted if you have the presence of jet streams in that area. So that is why these jets, they tend to isolate the air masses from one area to another. Now, this can have disastrous consequences also, many disastrous consequences. For example, let's suppose if I bring your attention back to this particular image, let's suppose here we have a jet stream. Over the region of North America, ideally here, you will have which kind of wind systems will be moving here? Which are the wind systems which are prevalent in these latitudes? At least take a look at the direction that I have drawn, my dear friend. The genius is okay. So basically, in the temperate regions, you have the movement of the westerlies. The westerlies moving from west to east direction. We can also say that the westerlies are the example of warm advection because they bring tropical air into the region of the temperate region or the subpolar region. So we have also seen the westerlies to be the examples of warm advection. So in certain areas, we can also think that the westerlies will lead to or account for the increase in temperature. When we talk about the regions such as Canada, US, or the other regions of North America, during the summer season, these areas they get heated up. These areas, let's suppose they get heated up. Now, listen to this carefully for the next 2 minutes. During the summer season, these will get heated up. Plus the movement of the westerlies in this area, that will further increase the temperature because the westerlies are examples of warm advection. So that means in this area, what I have is the presence of warm air, very warm air. Ideally, wherever you have very warm air, cold air from the nearby region can come in, moderate the temperature. Isn't it? Cold air from any region can come to that area of warm air, can cool down that region. Under normal circumstances, the polar winds can come and cool down that area. But here, you have the jet. The jet stream won't allow for the polar winds to come in. So what will happen? Can I say that the temperature of this region continues to increase? Because the jet streams won't allow the cold polar winds to moderate the temperature. Can I say that the temperature in the region of Canada, and same in the case of Siberia also, they will continue to increase as long as the jets don't allow the cold polar winds to come in? Fair enough. Now, let's suppose the region has gotten significantly heated up. Very high temperature, 30, 40 degrees Celsius at these latitudes is very high temperature. Now, on top of this region, you have the movement of these jet streams. These jet streams don't allow for the intermixing of air. Even if the region has gotten very hot, the air will tend to rise up. Thermal conditions. The air tends to rise up rather than being allowed to rise up to the extent and mix with everything. This local movement of air, which could provide for the local convectional clouds, bring some relief rainfall in certain areas. But here, because you have the jet stream, this jet stream will push back that rising air. Imagine you have a consistent river of air moving here. In certain localized area, because of excessive heating, the temperature has increased to 35, 40 degrees Celsius. So air has started to rise. It hits the jet. Again, it is reflected back. So while it is coming back down, can I say that the air will experience cooling or heating as the air is being pushed down again? Will it experience cooling or heating? What do you think? Why? If cooling, why? If heating, why? Good. Prerna, Anjan. Why I'm saying good is because initially itself they have given the reason also. Yes, most of you are correct. So there will be heating. Why? Because of adiabatic compression. So adiabatic compression, as this air is coming, being pushed down by the jet stream, there will be adiabatic compression, and that adiabatic compression means heating. So that hotter air will again heat this ground surface. Low pressure will get further accelerated, the temperature will further increase. Again, the air will rise up, again, it will hit the jet stream, again, it will sink down, further accelerating. So the temperature will continue to rise up. But Because there is this jet stream in existence, the cold polar winds are not allowed to come in. So the temperature, regardless of everything, will continue to rise up. This is the reason why the regions of Europe, Canada, Siberia, in the past 3 to 4 years, if you take a look at the climatic data of these areas, you would find that the temperature that they experience is extraordinarily high. Very high temperature is what they experience. And the reason for that is the obstruction caused by this jet stream. And that is why, because these jet streams have a kind of a meandering feature, they experience this phenomena. For example, Canada, Siberia, they experience this phenomena that the ground has got excessively heated up. Cold air is not allowed to come in because of the presence of the jet stream. So the temperature keeps on rising. As the temperature keeps on rising, localized areas, they experience that convection, rise of air, but the air hits that jet stream, is pushed down, creating high pressure on the ground. And again, rise of temperature. So you have high pressure now on the ground as you have the sinking air. Eventually, this will get created into a high pressure. So on the ground, you have high pressure. High pressure means no clouds, higher temperature, clear sky. Again, let's suppose that due to very high temperature, you have a localized low pressure rise of air. Again, that air will be hit back. It will lead to a high pressure. Again, creating to higher temperature. This is the reason where you would have come across instances where in Canada, temperatures during the summer nowadays have been rising to the level of around 45, 48 degrees Celsius. In Siberia, 45, 48 degrees Celsius. In Britain, in UK, you have temperature of 42, 43 degrees Celsius, where you would have seen that horrific images or laughable images, howsoever you put it, where you have the traffic lights themselves melting, the tar on the roads melting, various infrastructure basically forming into a liquid. It is not as if they are having a temperature of 100 degrees Celsius. For us Indians, 42, 43 degrees Celsius is a higher than average warmer condition. 45, 48 degrees Celsius, we say it is very hot. So I won't go during the daytime. During the evenings, maybe I will go out. In those areas of higher latitude, 45, 48 means an extreme calamity that they have never witnessed. Many of the people have not witnessed in their entire lives. So think about the impact on the flora and fauna. Many hundreds and thousands of organisms, they died because of this continued heating, because of the presence of the jet stream. This is the reason, or this entire phenomena where the warm air rises up is pushed down by the jet stream, causing again a continued heating. This was what was known as heat dome. Because it creates a kind of a dome-like phenomena where the warm air rises up, it is again pushed down as warm air, in that case, leading to further accelerated heating. Now, it has always been the case that warm air, cold air, jet streams, why is it nowadays it is more increasing? That is because due to global warming, the difference in temperature in many of the cases are being accentuated, sometimes are also getting weakened. Sometimes these differences of temperature, they are weakened, sometimes they get stronger. Sometimes it does happen that tropical regions, they get heated excessively. So when you have sudden very high temperature, that is when the difference in temperature between this area and the polar area will become very high. So the jet stream becomes very stronger. It doesn't allow the mixing of air. So that is the reason why for the past few years, the regions of northern hemisphere has been experiencing extraordinary amount of heat. That is known as the concept of heat dome. So The fast moving air currents in a jet stream can transport weather systems across the world, affecting temperature and precipitation. So they play a key role in determining the weather because they usually separate colder air to the warmer air. So they do not allow the air to mix. So certain areas can experience heat waves, and certain areas regions can experience very cold conditions. These conditions prevail as long as the jets streams are in existence, or till they shift north or south. Okay. Now, coming to the question which has been asked from this area. So, consider the following statements. Look at the statements. Jet streams occur in the northern hemisphere only. Only some cyclones develop an eye. The temperature inside the eye of a cyclone is nearly 10 degrees Celsius lesser than the surroundings. Which of the statements given above is or are correct? Krishika, is jet stream is a permanent concept? It is a permanent phenomenon, if that is what you are asking. Khushi, in fact, see, jet streams, wherever they are present, till that you will have warm air and cold air. So mostly jet streams will follow the path of the fronts. Wherever the fronts are there, there you will have the jet streams. So here majority of you have given the correct answer, which is good. So jet streams occur in the northern hemisphere only. Incorrect. Only some cyclones develop an eye. This is definitely correct. All the tropical cyclones will develop an eye. Only few of the temperate cyclones will develop an eye. Not all the temperate cyclones will develop an eye. The temperature inside the eye of a cyclone is nearly 10 degrees Celsius lesser than the surrounding. What is the temperature in the eye of the cyclone? Is it going to be 10 degrees Celsius lesser, 5 degrees Celsius lesser? What is the temperature inside the eye? We do know that the temperature in the eye of the cyclone is higher rather than lower. The temperature is higher. You know, this is also a trick that UPSC plays. Most of you would be aware that the temperature in the eye is higher. But if UPSC would have simply mentioned that the temperature inside the eye of a cyclone is lesser than the surrounding, you would have focused upon the fact of whether it is lesser or higher. But the moment UPSC gave 10 degrees Celsius lesser, that confuses your mind into thinking that, okay, maybe I would not have studied this properly. Maybe it is 5 degrees Celsius, maybe it is 2 degrees Celsius, maybe it has not been taught to me. But if it is saying 10 degrees Celsius lesser, might be somewhat lesser. This is what is known as confusing with data points. So please be on the watch for this kind of a confusion. Okay, don't get confused by these. Right. So this is also incorrect. So the correct answer will be C2 only. With that, we take a break. And then after the break, we come back. So take a break. Come back at 7. That is when we continue. That is when we'll address the questions also that you have. So let's take a break till 7 p.m. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. Ankush, you had a question that why jet streams are not mixed with another winds due to friction and why they don't exchange their temperature in the conduction process. So, see, first of all, air is not a good conductor of heat. So, that goes your entire premise of the air getting that temperature transfer due to conduction. Now, the jet streams, they move across a very wide band. So, in the peripheral aspect of this movement, in the periphery, there is some dilution which will happen. That is why they are not fixated in their paths. In sometimes they will get stronger, sometimes they, in a temporary region, they might disappear altogether if there is no temperature difference. So this is the reason why, even if you take a look at the images that I have indicated of the jet streams, let me show or bring your attention to this jet. Observe this. This jet is moving like this. Ideally, it should have moved like that for the entirety of the planet also, but it is not. Observe here, it weakens and almost disappears. There is a polar component associated there. And then there is a subtropical component which picks up from here. Right. So that is basically, sometimes it might entirely have this pathway, sometimes this path might be well developed as well going ahead into the future. So it is not fixated, it is something which is transient and discontinuous. Now, then we come to the portion which is in the entirety of the syllabus of geography. If you consider any area to be very conceptual, it is the portion of Indian climate and Indian monsoons. Now, monsoon is a phenomena. Saying that it is complex will be a massive understatement because till now, the scientists, the meteorologists, the climatologists of the various parts of the world, they still try to understand this phenomena of monsoons. Now, monsoons, they are responsible for rainfall in India. Almost 80% of our 70 to 80% of our average annual rainfall is received in those 2 to 3 months when we experience the monsoon season. That is when we have majority of the rainfall experienced over India. So when the monsoons are stronger, when the monsoons are normal, it is a good fortune and it brings forward, it is a harbinger of good news for India, because in the rural areas where agriculture is still one of the primary mainstays, in the rural areas, there normal monsoons means crop productivity. Crop productivity means sources of income for the farmers. Sources of income for the farmers means they can buy something, they can create demand in the economy, and the economy functions superbly well. But if there is an year of deficient monsoon, if there is one particular year where the monsoon rain has basically not occurred to the expected amount, in that situation, in those particular cases, what do you experience? You experience a substantial fall in the crop productivity. You experience difficulty in terms of the rural economy that impacts the national economy as well. So that is why when the economic survey is also presented in the later part of this month and in the first week of next month, I'm sure you will also be looking out for the economic survey. So when the economic survey is published, where the government charts out the entire details of the economic scenarios, what are the major things to look forward to, or what are the major challenges, monsoon and monsoonal performance is always a key indicator that can provide an uptick to the economy, or that can bring down the economic growth. Because still, believe it or not, around 50% of our agricultural farmlands, 50% of our agricultural farmlands, they are dependent on the monsoonal rainfall only. So that is why monsoons are very important. Historically, it has been very important. Whether you are living in northern part of the country, southern part of the country, Eastern part of the country, western part of the country, central part of the country, coastal part of the country, interior part of the country, wherever you are living in. Observe the local culture, local traditional culture. You'll find that monsoons, there is always a kind of a festivity, a kind of a traditional um, sort of reverence which is provided. You basically have all the various cultures in our country. They have some or the other practice of worshipping the nature gods so that the monsoons come out to be normal. For example, if you go to the region of Nilgiris in the southern part of the country, you'll find that certain types of trees they are worshipped for the normal monsoons. So, in our history also, monsoons have always been given that reverence. Everybody knows that starting from the month of June onwards, the country is going to receive rainfall, and this is going to continue. Having said that, what is the meaning of monsoon? What do we understand by the meaning of monsoon? So, in its literal translation, monsoon comes out from the term mosim, the Arabic term mosim. From that, the word monsoon has been derived. So, it has been derived from the term mosim, which basically means seasons. But when we say monsoon, so mosim has basically been translated in various different areas, or that word has now become monsoon. Monsoonal type of climate, wherever you find or wherever you hear the term monsoon climate, it basically tells you that there is a seasonal reversal of the wind direction, a complete seasonal reversal of the wind direction. What does that mean? That means if in certain seasons the wind direction is like this, then in the later part of the year or in other part of the year, the wind direction will change, can revert as well. So monsoons refer to seasonal reversal of wind. Now, for the first time, this monsoonal phenomena, while for us Indians it was always known, but for the first time when we talk about the regions of the globe, now Arab travelers from beginning of 9th century, 10th century onwards, the Arab travelers they dominated the trading scenario, exchange of goods. They would basically travel to various different places. Now, these Arab travelers, they basically came across something unique. When they would come to India from the region of Middle East, if you come to India, obviously you will come through the region of Mediterranean Sea, isn't it? So the Arab travelers, they basically found a situation and they utilized it, they exploited it quite substantially as well. And that was the fact that when they would come to the Indian coastline during the month of June, and they were aware of this, that during the month of June, July, August, the wind direction over the region of Arabian Sea and Indian subcontinent would be southwest to northeast. They would use these winds to come to the Indian shore. They would basically bring their boats, and with these boats, they would come to India for trade. They would exchange the materials, sell those materials, whatever. And then again, they would find out that during the months of October, November, December, January, the wind direction reverts. It completely changes and reverts. And they would characterize this as monsoon. Mosim, seasons, From that season came the existence of monsoon. Now, earlier, our understanding of monsoon was always provided by many of the climatologists across the globe. They've tried incredibly hard to understand the case of the monsoons. The simple explanation initially provided was the fact that, look, during the summer season, the Indian landmass gets superbly heated. Bay of Bengal and Arabian Sea tend to remain cooler in comparison. So, those are the regions of high pressure. Land area becomes the region of low pressure. Winds come from Arabian Sea and Bay of Bengal over to India. They bring rainfall. Now, this was an accepted phenomenon, thermal aspect or the thermal theory regarding monsoon. This was an accepted phenomena which prevailed for a couple of centuries. Later on, people came to know that this monsoonal rainfall, if it would only have been the heating of the land and cold air and moist air coming from Arabian Sea and Bay of Bengal, that would mean that every year you should receive a similar amount of rainfall. Why is it that in certain years you receive 80% of average annual rainfall? In certain years, you end up receiving 110% of average annual rainfall. Why is that sudden variation? Why is it the case that sometimes the onset of monsoon happens on 1st of June, sometimes on 7th of June, sometimes on 27th of May, sometimes on 25th of May? If only low pressure and high pressure would be the determining factor, then every year the onset should also happen on the similar reasons and the similar time. This is what got the people thinking. And people understood that monsoon is actually a complicated phenomena. There are multiple factors which basically influence the monsoon. Greater advancements were made into the study of monsoon during the era of the 70s, 80s onwards. It was during this time when India and Soviet Union of that point of time, today's Russia, we had a very close collaboration. So, scientific collaboration also. Like right now, India has got a good scientific collaboration with the US. At that point of time, we had a good scientific collaboration with the Russians or the Soviets. So, India and the USSR, they together launched a monsoon expedition into the Indian Ocean to study about the various phenomena and influences which actually can influence the movement of these winds. What was known as the monsoon exercise or MONEX. That was one of those basic monsoon experiment rather. So this MONEX in various different phases, MONEX 1, MONEX 2 happened. That further increased our understanding about the monsoons. But it is not complete. Later last year, as in the mid of 2023, almost in the month of August and September, you had another research paper which was filed by an individual from Indian Institute of Tropical Meteorology in Pune. Basically, the scientists, they have claimed that the heating and cooling of northern Atlantic can influence the monsoon. Because again, details of the research paper not required for your GS, but just I'm giving you a preview. The argument in that research paper is simple, that if let's suppose the northern Atlantic experiences overt amount of melting, excessive amount of melting, or very limited amount of melting, that would influence the polar winds, the high pressure at the poles. So the polar winds will get impacted. Once the polar winds get impacted, the polar jet streams will get impacted. Once the polar jet streams get impacted, the subtropical westerly jet streams will also get impacted. And their influence will have a direct consequence on Indian monsoon. So it is dependent on many factors. Many of them we are still trying to understand. As we speak, there I have already told you that there is an ongoing mission where the Indian scientists and the American scientists, they are trying to understand whether this MJO phenomena can have any influence on the causation or occurrence of ENSO cycles in the Pacific Ocean. So it is still a continuing study. It is still a continuing process. 10 years down the line, we might know newer things about the monsoon. Today, we know much more than what we knew 15 years back. So, it is a kind of a thing which we get to know more and more. I also gave you the example about the extent of the influence on Indian monsoon by various factors, where basically you would have seen the prediction that this year we are expecting 93% of average annual rainfall. This year we are expecting 102% of the average annual rainfall. How do you get those predictions? Do you think few individuals, they sit down randomly on a piece of paper, they close their eyes, they put their pen on one number and they say, okay, 93%? Does that happen? No. That prediction happens with the help of supercomputers. You feed in the temperature in the entire modeling and simulation system. You feed in the temperature at Eastern Pacific, Central Pacific, Western Equatorial Pacific, Eastern Indian Ocean, Western Indian Ocean, Northern Atlantic, Central Atlantic, because the circulations, the jet streams, how powerful they are, in which time of the year. And accordingly, it gives you the generation of that simulation that this year we are going to experience normal rains or deficient rain or excessive rains. So, this is when once quite recently, this was the case, where the prediction offered was that of a deficient rainfall, we received excessive amount of rainfall. Upon investigation, it was found out that while feeding the data pointers, there was a discrepancy in the second decimal places. For example, what could have been 0.02, in that place it was 0.07. So the entire prediction system changed. That tells you how sensitive and how dependent monsoon system is on a variety of circumstances. So here, we will try to understand this process. Now, I would want you to concentrate on the PPT and the session here, because in the books you will find the monsoon to be talked about or taught about in a certain manner, that low pressure on the ground surface attracts winds, which is true to some extent, but that is nowhere enough explanation for the entire phenomena of monsoon. So over the ground surface you have low pressure, over the water body is high pressure, occurrence of ITCZ, shifting of ITCZ, causation of rainfall. This region receives that much rainfall, that region receives YZ amount of rainfall. Here, what we are going to do is we are going to follow a different approach. First of all, we are going to take a look into the details of the factors which can influence the monsoon winds, which do influence the monsoonal phenomena. Those factors are something that we will concentrate upon. Each of these factors we will understand, and then after that, let's suppose after that we will try to go through and weave a story around the entire mechanism of monsoon. We will bust certain myths also here, where majority of the books they will tell you that retreating monsoon and northeast monsoon is the same. I will stand here to argue in the opposite. I will tell you both of them are different. There's a difference between the retreat of the monsoon and northeast monsoon. So there are going to be various different substantial portions which you will not find in the book. So kindly, please do refer to the PPT and the class lectures. Any point of time you have doubt, maybe 1 year down the line, you finally decide to revise the portions because you realize that you have to revise in order to get success in this examination. So let's suppose 1 year down the line, you face that issue. Don't look here and there and search frantically for random notes or random particular lectures. I would always advise you, it is up to you, even though it is your decision. I would advise you, even at that point of time, take a look at the recorded lectures, get this portion from the recordings of the lecture. Okay. Now, before that, the customary portions which can be relevant for your prelims. So, for your prelims, first of all, factors influencing Indian climate, influencing Indian climate. Factors influencing Indian monsoon. This is the last conceptual portion in the entirety of climatology. After this global climatic distribution that we have to study, for that shifting of pressure belts and the permanent wind system should be internalized. After that, you can basically relax because the conceptual portions will get over. Then oceanography and Indian geography, they are not that very conceptual. They are very easy to grasp. Okay. Have we entered into Indian geography? For this portion, yes, Ankush. Basically, ideally, this is the portion for Indian geography. Why I have taken it up in the end or the fat end portion of climatology is because right now, that is at least my expectation right now, the portions of jet stream, for example, the portions of ITCZ tricellular model would still be very fresh in your minds. I'm not relying on your revision prowess. I have still got certain doubts about the combined ability to revise, so I'm not going to take the risk of teaching this 1 week later when I'm definitely going to face the question, please explain what are trade winds again. Why do the trade winds move only in this direction? Why do the westerlies not move over the region of Tamil Nadu? So that is why it is always apt to cover this portion now. After this, we will go to the portion of world climate, and then world's oceans and oceanography. Then finally, we'll enter into the remaining portion of Indian geography. Okay. Now, here, after this, you also have the portions of mechanism of monsoon, advancing and retreating monsoon, and retreating monsoon, then breaks in monsoon, rainfall distribution. When I say rainfall distribution, many of the candidates they start rote learning that how much amount of rainfall is received in which area. While fair enough, that is their discretion, I would advise you just have the common trend analysis, that how the amount of rainfall varies over one region to another. You can have an average idea about the total amount of rainfall. That is it. By the time that you cover the portion of the biogeography portion in Indian geography, that is forest and natural vegetation, I would ensure that by asking so many times the same question, I will try to drill it into your memory. So that is the expectation. So here, rainfall distribution, then western disturbance. Okay. For the mains exam, you will get questions from mechanisms of monsoon, this year you had a question which was asked directly from this area. I will mention that question as we move ahead about the explanation of the monsoon. Advancing and retreating. Variation and distribution of rainfall. Of rainfall. And then western disturbances. In Sunday's subjective test, questions were given from Indian climate. Bring forward that question in the subjective test. I had not given any question. Out of the five questions that you are talking about, I don't think there was a question for the Indian climate. But if it was there, you can answer it after this or share it with me, which is the portion. So these are the questions relevant. Hiren, what is southwest monsoon? Patience, my dear friend, is a very good virtue in life. Patience is something that will carry you to very far places. Have patience. We have not discussed about what is southwest monsoon, what is northeast monsoon. So here, first of all, we will be discussing about what are the various factors which influence the climate of India. Because when we talk about the climate of India, it is as varied as it can be. In the late 80s and the early 90s, there was a famous saying and the famous adage, which you'll find in the accounts of many of the geographers who basically mention if you want to study the climate of the world, just study India. If you want to, it was actually if you want to study the world geography, just study India. It will give you an idea about the rest. So that has always been the case. From extreme cold conditions in the north to moist and warm and humid conditions in the south, to some of the driest deserts in the form of Thar, to the rainiest area across the planet in the form of Cherrapunji and Mawsynram. From extremities of temperature experienced in inland areas in the north to very moderate and fixed climatic conditions of the south, we do experience a variety of climate. And the location of the country is such that we get all the various different seasons: summer, winter, spring, autumn, all of that is something that we experience. Now, part of that is attributed to the location of the country, the latitudinal extent of the country. The latitudinal extent of the country is such it lies completely in the northern hemisphere, completely in the region of the northern hemisphere, and Tropic of Cancer almost passes through the center of the country. Now, that means to the north of Tropic of Cancer, we do experience a kind of a subtropical climate, and to the south, we experience tropical, equatorial kind of a climate to the extreme south. Right. On 21st of June, the sun shines almost vertically over Tropic of Cancer, but such events don't happen to the north of Tropic of Cancer. So it is because of the latitude and the latitudinal position. Imagine if India would have been in a place where equator would have passed through the center of the country. Then we would have experienced similar climatic condition throughout the year. Imagine if India would have been a country which would have been situated completely to the north of Tropic of Cancer. Our climatic conditions would have been very different. We would have experienced very cold conditions. So our location, the latitudinal position with the Tropic of Cancer passing through the center and India entirely being in the northern hemisphere, that is what allows us to experience a variety of various different seasons, tropical, subtropical, and in certain areas, even temperate climate is experienced. So here, India lies to the north of equator in northern hemisphere. Tropic of Cancer passes through the center of the country. Okay, almost to the center. Don't hold me to this that you said it is exactly at the center, but exact center is this. Almost to the center. So due to which we have a wide range of variations. Having said that, in the location where our country is situated, if you look to the west from our country, you will observe be it Pakistan, many areas of desert, Iran, Daste Lut, Daste Kavir, one of the driest deserts, then Rubal Khali in the Arabian Peninsula, Saudi Arabia, again a desert, Sahara, again a desert, Then in North America, you have the Mojave Desert, the Chihuahua Desert. All of these are deserts at the same latitudes. So our latitudinal extent where we are, that is the region of subtropical high pressure. Around 30 degree, 25 to 30 degree, you have the subtropical high pressure, which means lack of rainfall. But we experience monsoonal rains. Why does that happen? For that, one of the most major role played is by the Himalayas. The Himalayas, which form what is known as the natural frontier of the country, they are the guardians to the north. Himalayas, they not only provide as a kind of a barrier to the north, not only facilitate in national security and basically historically, if you take a look at the Himalayas, Himalayas have protected us from a variety of various internal or external threats. From the time of Attila the Hun to the time of the Kublai Khan, the Mongol king, the Himalayas have protected us significantly. Plus, on top of that, Himalayas, they are also the providers of the various rivers, which directly or indirectly ensure the food reaches our mouths for the crores and hundreds of crores of Indians. Right. So that is why Himalayas are very important for our lives. Having said that, they play a much greater role in influencing the climate. Imagine if the Himalayas would not have been there. Moist winds being carried by the winds, moist winds coming from the region of Bay of Bengal, these moist winds would have straight away moved to the north. So these areas would have been very, very dry. Again, imagine if the Himalayas would not have been there, even the moist winds from the region of Arabian Sea would have simply moved northwards. The entire region would have been very, very dry. The Himalayas form a barrier. Now, when they form a barrier, then what happens? That basically means they have the ability to cause orographic rainfall. In this entire vicinity, they cause rainfall. Substantial amount of rainfall. Okay. Other than that, during the winter months, I hope you recall something that we have studied as the Siberian high, a pressure cell, a high pressure cell, which is formed in the region of Siberia during the months of December and January. Siberia means northeastern portion of Russia or northeastern portion of Asia, eastern portion of Russia. Now, Siberian high drives cold winds from the region of high pressure winds emanate. Had Himalayas not been there, the very cold winds from the region of Siberia would have come into the region of the northern plains. The winter that you are experiencing now would have been to the extreme. The regions would be covered in ice and snow for substantial duration. So imagine no Himalayas. There is no relief rainfall, nothing to stop these moist winds, and during the winter season, you have cold conditions. Again, lack of rainfall. You have a desert. So the only thing which protects India from turning into a desert is the monsoon along with the Himalayas. The monsoon phenomena is the one which ensures that India is not a desert and that the Himalayas they facilitate that monsoonal process. Now, why I have talked a bit detail into the Himalayas because you do get such kind of questions that elaborate upon the role of Himalayas for India. Now, in that, you cannot only say about climate. You have to talk about the river systems also. You have to talk about the national or the natural frontier also, or protection from the north also. All these factors you have to talk about. Okay. Now, after this, you have a significant role in facilitating the amount of rainfall, the type of climate experienced in a region that is dependent and influenced by the relief features. And what relief features are we talking about here? That is basically the physiographical barriers that you have, the relief features. For example, in certain areas, let's suppose you have a mountain or a hill. Now, ideally, we do know that you have a windward side and the leeward side. This side will be known as the windward side. This is the one which will get the winds. This side is known as the leeward side. So here on the windward side, you would expect the winds to rise up. As the winds rise up, they form the clouds. These clouds will bring substantial amount of rains. Whereas on the leeward side, you will have lack of rains or the rain shadow zone. Now, the presence of various hill systems and the mountain systems across the country, that ensures the occurrence of rainfall in various different paths. So here, physiography or relief also affects the temperature, air pressure, direction, and speed of the wind, and the amount and distribution of rainfall. Windward side of Western Ghats, for example, they will receive very high amount of rainfall. Even the windward side in the region of the mountains of the northeast, the Purvanchal Hills, there also. Whereas the southern part of the plateau, that remains dry, or the region in the central portion of peninsular India remains dry because of it being on the leeward side of Western Ghats. Let me elaborate upon this. So here, when we talk about the relief features, more or less, this is the broad delineation of the relief features. Here, let's suppose you have the three ranges of the Himalayas. Let's suppose you have the three ranges. Here you have Garo, Khasi, Mikir, Bareil ranges, Lushai. Right here you have the Vindhyas, the Satpuras. Now, when the moist winds they come towards the Indian coastline during the time of the monsoon, they come from this direction and this direction. Now, as they come from these directions, first of all, they will hit the western part of the Western Ghats here. That is where, first of all, the winds will hit. So here they will cause very heavy amount of rainfall. Then slowly and steadily rainfall will be caused here in these areas. These regions remain dry because it is on the leeward side. Then moist winds from Arabian Sea, they basically get channelized between Vindhyas and Satpuras. They reach central India, hit the Amarkantak hills and the Amarkantak plateau, causes rainfall. Then here, the region of Bay of Bengal. These winds, they will hit the mountain barrier, they will cause rainfall here. After this, the winds will get diverted. One portion will move here, another portion will move here. Right? The portion which gets trapped in between the mountains here causes tremendous, excessive amount of rainfall in the northeast. Now, here, what is the direction of the winds? In the region, for example, in West Bengal and Bihar, let's suppose Bihar, what is the direction of winds, the moist winds in Bihar that you can see from the image? East to west, right? Easy east to west. I told you that, and we have discussed it earlier also, that winds are oftentimes named after the direction from which they originate. So these winds which come from the east, in Hindi you refer to them as Purvaya. In Bihar, for example, it is referred to as Purvaya. Now, this was a question which was asked in UPSC mains this year, that Bihar experiences a wind which is known by the name Purvaya. What is this wind and what is the impact on Bihar? Many candidates, they panicked that I have studied everything. I did not come across this term Purvaya. Am I supposed to learn each and every language now? No. UPSC just wanted to check whether you can understand or analyze that in a region only certain kinds of winds will blow. So the winds from east, why will it come to Bihar? So the moist winds from here, they cause rainfall. Then, for example, here, from the region of Arabian Sea, if the winds move over. So always understand, in the mains exam also, it is not that the questions are very tough. They want to disturb your own inner peace. That is the purpose of the entire question paper, of that stress test. So as long as you are able to decipher these in the simple language, you will be in a good place. Now here, observe these winds, they will hit the southern part of the Aravallis. So in the southern part of Aravallis, they might cause some amount of rainfall. But for the rest of the area, they will move parallel to the Aravallis. So as they are moving parallel to the Aravallis, will this region experience rainfall at all? Here, there is no such barrier. No, they won't receive rainfall. Western Rajasthan is dry, a desert. Let's suppose the winds from the east, the moist winds from the east, they come over. Now here, when they hit the Aravallis, they will cause rainfall in the region around Kota, eastern part of Rajasthan. Western part of Rajasthan will be on the leeward side of the Aravallis for these easterly winds. Again dry. These winds, however, they move forward, hit the Himalayas, cause rainfall. More moist winds come over. Some of them will hit this also. They will cause rainfall here also. By the time that they move northwards, they would have drained their amount of moisture so much, amount of rainfall would reduce. By the time that you reach the region of Ladakh, will the air have moisture left in it? Almost no. That is why Ladakh is a cold desert. So relief features have got a very important role to play in terms of influencing the amount of rainfall. For example, when the winds are coming in this direction, can you imagine a scenario where if I say that the Coromandel coast or the eastern coast, they are almost parallel to the direction of the wind, so no rainfall. So that is why no rainfall. So the physical features, the physical foundations, the topographical variations, they have got a substantial role to play in terms of influencing the amount of rainfall across the country. These are few of the examples that you have to cite. If a question comes, how is it that relief features can influence the amount of rainfall in India? You have to describe these in detail. Okay. Now, another factor which plays a major role in influencing the amount of rainfall received in India is the fact that India is surrounded by water bodies from three sides. That is why it is also what is known as a peninsular landmass. It is surrounded by the water body from three sides. So what are the influences? There are two influences. The first influence is during summer. What happens during summer? So during summer, the landmass gets heated up. During the summer season, during the month of April and May, what is the temperature? the temperature experienced is in the range of around somewhere in the range of 45, 46, 47 degrees Celsius. That is the temperature which is experienced, isn't it? In certain areas, water body, tropical waters, on an average 24, 25 degrees Celsius. So during the summers, these become regions of low pressure. Various low pressure cells are formed. And then comparative high pressure is present here. Winds always blow from a low to from a high to a low. So winds will be attracted. So that is why during summer, heating of the land creates a low pressure. Heating of land creates a low pressure which attracts winds from nearby waters and causes rains. Imagine if India would have been a landlocked country, surrounded by land from all sides. Regardless of how much heating during the summer, it would never have got those kind of winds into its place. So not that much amount of rainfall, right? Then another reason or another impact of that distribution of land and water is basically observed in the moderate temperature experienced in coastal areas. So moderate temperature experienced in the coastal areas is because of the frequent movement of the land and the sea breeze, which maintains the temperature. So across a large coastline of almost 7,500 kilometers, but let's suppose 7,000 plus kilometers if I say frequent occurrence of land and sea breeze moderates the temperature. Frequent occurrences of land and sea breeze that moderates the temperature, and also you will have the case where you will observe the scenario where let's suppose the moisture content and the interior areas they have extremities of temperature because of lack of this, right? Because of dry air also, interior regions experience extremities of temperature. The interior regions they experience extremities of temperature. Okay, now by the way, I'm just prodding here, guys. I'm just pricking and trying to understand. If I ask you a question that talk about the reason why the region of Mumbai, let's suppose with the same amount of emission, experiences lesser pollution as compared to the region of Delhi. will you be able to talk about climatic factors which can lead to the case that Delhi experiences much greater amount of pollution in the air as compared to the region of Mumbai or Kolkata? Will you be able to write? If yes, what are the key couple of points or key couple of words which you think is the reason attributable for Delhi experiencing that extremity of pollution, whereas the regions such as Mumbai, etc., there you will have lesser pollution load? Very good. Vishal, movement of wind. Prerna, Delhi has temperature inversion. Very good. No vertical movement. Yes, Vikram, about temperature inversion. Very good. Beautiful. So this was a question which was again asked in mains examination. It was a question which was asked for the portion of environment ecology. You know various sources of air pollution in Delhi. You will study it in environment ecology whenever, if you have not studied, whenever you will study about that. So that should not be an issue. But while majority of the candidates will only focus on the fact that stubble burning in the region of Delhi, more vehicular emission in the region of Delhi, industrial pollution in the region of Delhi, if you want your answer to stand out, you have to pitch in these geographical pointers also. That is what is going to make your answer much more diverse. And please, that is something I want you to internalize. That interconnection between different topics and different subjects, that is always going to be very rewarding in the mains exam. Otherwise, everybody gets that same average marks. Okay, very good, very nice. Now, then there is another factor of altitude. When we say altitude, we mean the height variation. Now, we do know, for example, Shimla, for example, Uti, Darjeeling, Dalhousie, Dharamshala. These are the places which are situated at a height. These are the hill stations. Now, at the similar latitude, if you have a region which is closer to the sea level, they will experience higher temperature. The regions at an altitude, they will experience very cold conditions. For example, in Uti recently, that is in the last week of December, you had the temperatures which were so low that there was frost formation. In many places on the ground, there was the formation of frost. It is a different matter that the social media experts and the travel blog influencers, they immediately called it out that Uti has received the snowfall and I am the first person recording this snowfall. It was not a snowfall. It was a frost formation. I hope now you guys are smart enough and intelligent enough to identify the difference. So, basically, due to the variation of altitude, you will have a variation in climatic conditions, in temperature conditions also. So, because of lapse rate, the temperature decreases with height. For example, Agra and Darjeeling are located on the similar latitude. Elevation of Darjeeling is 2 kilometers above the sea level, and Agra is 171 meters above the sea level. But temperature in January on an average in Agra is around 16 degrees Celsius, where it is around 4 degrees Celsius in the region of Darjeeling. Okay? Yes, Prem. That would be very nice way to answer. But sir, as monsoonal winds go parallel to the Satpuras and Vindhyas, but still in areas nearby we experience substantial amount of rainfall. Why? See, for most of the region between Vindhyas and Satpuras, the winds will go straight through. But you have to understand that we are looking at the larger picture, at the local picture, at the very small micro level. You will basically agree with me when I say that the winds can face isolated barriers. It is not as if Satpuras are drawn on a straight line. You will have some hill here, some hill here, some hill maybe here, some hill again here. So as the winds are coming, these two hills, they will stop that wind movement, they will cause rainfall in that area. So like that, You have that regional micro variation which cause rainfall. But that passage between Vindhyas and Satpuras that carries the winds to the region of Amarkantak in the region around Madhya Pradesh, Chhattisgarh, bringing rainfall in that area. Otherwise, that region would have been very dry. It is the rainfall which is brought into that area that the region of Amarkantak becomes a source of multiple rivers from Narmada, Son, Rihand, Mahanadi, many of them. Okay? I hope that is understood, Vikalp. As moist also come from the west as it does not cause rain in the leeward side of the Aravallis. No, there the portion of the winds, the Arabian Sea winds, they move parallel to the Aravallis. That is why they don't cause rainfall. Can westerlies act for pollution in Delhi? Yes. The westerlies during the winter months, they bring the pollutants from the, sometimes they bring a lot of dust particles from the nearby deserts. Sometimes they carry dust particles all the way from the Iran Balochistan region. Sometimes they carry the smoke of stubble burning and pollution in Pakistan that is also brought over. So multiple things are carried over by the westerlies. Okay, are we comfortable up till now? Good, because now we finally move to the factors influencing the Indian monsoon. Now, in each of these portions, we will study these separately. For each of the slides, I have ensured that there is that written text in the PPT itself. So, for the next half an hour, as long as the class will proceed, I want your 100% attention here. 100% attention, please give it here. You will more or less be able to understand. This is not rocket science. This is not Schrodinger's principle that you have to understand. This is a very simple thing. So, there are various factors which influence the Indian monsoon: differential heating and cooling of land and water, the shift of the position of the ITCZ during the summer seasons, subtropical westerly jet stream. It is one of the most important factors when it comes to the onset of monsoon. Onset of monsoon. Heating of Tibetan plateau and tropical easterly jet stream which gets generated. This is a temporary jet. We'll talk about how this temporary jet gets generated, why this temporary jet gets generated in the first place. Then Mascarene High. I had told you to map out Mascarene Islands in the Indian Ocean. Are we aware about where the Mascarene Islands are? Only one of you is saying yes. Okay. Few of you are saying yes. Good. These Mascarene Islands, they are the high pressure which drives the winds towards the Indian subcontinent. So the strength of the Mascarene High is very important for the strength of the Indian monsoon. If this Mascarene High gets stronger, Indian monsoon will get stronger. If this Mascarene High gets weaker, lesser rainfall in Indian monsoon. Then Enzo phenomena, they also influence Indian monsoon. And then you have the IOD. They will also influence the Indian monsoon. So first of all, let us start with the heating of land. Now, here, during the summer season, first of all, let us draw the equator. For every image, we will be drawing the equator. Rough, obviously. Let's suppose this is the equator. Now, during the summer season, by the way, when summer season in the north, it is winter season in the southern hemisphere. So all the pressure belts, they have a tendency to shift north. Having said that, the land areas across the northern part of the country, across the central part of the country, they start getting heated up very significantly. For example, the heating it is not as if heating will start from the region of Delhi and the region of Punjab, UP, Bihar, like that. No. During these months, during the end months of, let's suppose, January itself, go to the western coastline of India, southwestern coastline of India. It is scorchingly hot. It is not very hot that the temperature is around 40 degrees or 45 degrees. No, but the temperature is in many places is already around 25 to 30 degrees. Right? During the month of February, go into the interior areas or the coastal areas of Karnataka. Temperature is high, very high. By the month of March, peninsular India starts getting heated up. It is still pleasant in the north. Then, from April onwards, for the past few years since 2022, we have experienced heat waves during the month of March itself. In fact, in 2022, one of the major reasons for the loss of wheat crop, for which India had to ban exports of wheat, was the occurrence of heat wave in the month of March itself. Ideally, heat waves or very high temperatures are something that we generally expect it to occur in the month of maybe a May or a June. But here the heat waves, sometimes they start from month of March, April. By the time that you enter the month of April, it starts getting very hot. In the northern part of the country, by the time that you enter the month of May, temperatures in Rajasthan easily cross 45 degrees. Temperatures in Punjab easily cross 42, 43 degrees. The temperature in Delhi oftentimes crosses 45, 47, 48 degrees. UP, Bihar, Madhya Pradesh, temperatures are on the rise. So, because of that very high temperature, you have a low pressure which is created. Meanwhile, the water bodies, they also get warmed up. But will the water bodies ever experience a temperature of 40, 42 degrees Celsius? No, never. Before that, such significant climatic disasters will happen. For example, earlier this year and even last year, Arabian Sea gained a temperature of 33 degrees Celsius in certain areas. You had a series of cyclones which continued to develop. One after another, cyclones will continue to hit. They will cool down the temperature. They will lower down the temperature. So, water bodies are comparatively cooler. These cooler water bodies will have high pressure. These will have high pressure. So, winds will be attracted from high to low. That is the basic factor. Now, that was the first concept of the monsoon, the thermal concept of monsoon as it was. So, during the summer season, the land becomes extraordinarily hot. The nearby water bodies are cooler in comparison. As a consequence, cooler moisture-laden winds from these water bodies, they hit the land masses, causing rainfall. Sir, in coastal regions of India, we tend to experience equatorial type of climate. See the smart people, or A type, as per Köppen. That means winterless. So how can they have moderate temperature as compared to inner part of India? Please tell me how. Three question marks. Okay. So can we have a bit of a patience till the end of this particular chapter? Because Charu, your question has got a very simple answer. The very simple answer that we discussed way back in module 6. Regardless of howsoever you twist the question, you are playing the role that UPSC plays. Twist the question so much. Köppen climate also you have brought about, A-type also you have brought about everything. But first of all, A-type is tropical, it is not equatorial. AF is equatorial. In India, only few regions experience AF. Most of the regions experience AM. That is monsoonal type of climate. Having said that, there is only one reason which will suffice your entire question. And that is the fact that in the coastal areas, you have frequent occurrence of land and sea breeze on a daily basis. When you have the frequent occurrence of land and sea breeze, that will moderate the temperature. That will not allow the temperature to go to any extreme. Because during the day, when the land gets heated up, cold winds or cooler winds from the water bodies come up and they lower the temperature. During the nights, when you have the land getting very cold, the warm winds from the sea will again come. So that is basically the land and the sea breeze, which will create a moderate climate. Secondly, we have also seen that in the coastal areas, the amount of moisture in the air will be very high. When the moisture in the air is high, what is the lapse rate? Lapse rate is less, means the rate of reduction or variation in temperature is going to be very less. Heat is going to be retained. Whereas in the interior portions of India, far away from the coastline, during the summer, the land gets heated up. Will you have a cool breeze from the sea coming there? No, the heat continues. Now, during the winter, when the surface loses heat, if moisture is very high, the air would retain that heat. But in the interior, the air is dry. So basically, all that heat is lost. So summers are very hot, winters are very cold. So again, module 6, kindly revise. You will get the answer to that. Köppen classification is not covers. I know. That is why I said that smart students. There are many smart students. Basically, I recall this in school days, this was the case where, and don't take it negatively, Charu. It is good that you have studied to a higher extent. This was just a kind of a sarcasm. So I hope it is taken in a positive light, in a lighter note. But in school, we had this kind of a thing where many people, what they would do, they would study the next chapter beforehand and they would come into the class. And then the rest of the public would simply be staring at the blackboard, while few of them, they would ask the questions from the next chapter. It is, I hope that you are able to carry it on sustainably, because many of the times what happens is that in that rush to read the next chapter, the previous one is left behind. But I'm aware of this particular student, and this is a regular and a meticulous student that we are talking about. So, not much of that. So, here, when we talk about the other factors other than the heating of land, you have the shifting of the ITCZ. Now, as the land areas get significantly heated up, what happens? That there will be low pressure. Now, the low pressure means it will be a thermal low pressure. Now, the ITCZ shifts over India. The ITCZ basically during the summer season here. Observe the movement of the ITCZ. The ITCZ shifts to the north. During the month of January, the ITCZ is here. So, during the summer season, when the ITCZ shifts north, it sometimes lies above the region around the northern part of the country, around the region around the Himalayas. That is where the ITCZ does lie in the month of June and July. Now, ITCZ is a mixing or the meeting of which wind types? Which wind types meet at ITCZ? Tropical winds, trade winds, they meet at ITCZ. Trade winds from the north, trade winds from the south, they will meet at ITCZ, right? Now, let us understand this. So, here, first of all, during the summer season, now during the summer season, you will have a condition where, let's suppose, the temperature here is much higher than the temperature at equator. Temperature here is much higher than the temperature at equator. Temperature here is much higher. Temperature here is much higher. So the ITCZ eventually has to shift there. But that movement is not going to be a one-time movement, that suddenly that movement happens. Basically, that movement takes place gradually. So, in the month of, for example, March, as I told you, southern part of the country starts getting hotter. In the month of March, here, the ITCZ will be somewhere here, end of March. April, ITCZ will be here. In fact, if I talk about March, March is when the ITCZ is somewhere here. April, and through the month of April, ITCZ would have transitioned. Now, during the month of April, can I say that there is a pre-existing low pressure in certain areas of Bay of Bengal and Arabian Sea? Can I reach the conclusion that certain areas of Bay of Bengal and Arabian Sea will indicate a pre-existing low pressure because the ITCZ is there? When you have a pre-existing low pressure condition, which atmospheric phenomena is likely to occur? A pre-existing low pressure over the water body can trigger which atmospheric phenomena? A cyclone. Perfect. That is why in the later months of April, the cyclone season begins. In the month of May, the ITCZ will be somewhere here. Can I say that again, there can be probability of occurrence of cyclones during these months? Yes? So in the month of May also, you will expect formation of cyclones. Then in the month of June, by this point of time, the temperature has risen up quite considerably, very significantly. So in the month of June, mostly you will experience that the ITCZ would have already shifted like this. But sometimes what happens, the ITCZ is quite discontinuous in that pattern. Sometimes it is also like this. There also is a germination of cyclone. From here also, let's suppose the region around Lakshadweep gets superbly heated up. The cyclone will be carried here. So like that, even the month of June is a cyclone season. But by the mid of June or by the sometimes the initial portion of June itself, the ITCZ is fully and completely established here. ITCZ is an attractor of the trade winds. The northern trade winds, northeasterly trades, they won't be able to reach here so much because of the mountainous barrier in the form of Himalayas. They won't be able to reach here. What about the southern trades? Southern trades, which are, we have seen that rather than a pressure belt, you have pressure regions, high pressure and low pressure regions, which becomes the drivers and the attractors of the winds. So in the southern hemisphere, in the subtropics, you have a high pressure. That is the Mascarene high pressure around the region of Mascarene Islands. Those of you who have still not located the region of Mascarene Islands, I urge you, I request you that today after the session, take the help of Google Map, take the help of ideally your atlas, look at where this Mascarene Islands is situated. So here you will find the Mascarene high pressure. The Mascarene high pressure. This becomes a driver of winds. I'll show you the satellite image of the winds also. But initially, as the winds, they move, their destination is what? Where are the winds trying to reach? ITCZ. Their target, their destination is ITCZ. In the southern hemisphere, wind movement gets deviated to the left. So the winds will get deviated to the left. They will hit the region of equator. As they cross equator, at equator Coriolis force is absent. So as they cross equator, then they move to the north. Their destination is always the ITCZ. Okay. The winds will then start bending to the right. The shape of the Indian peninsula divides them into the Bay of Bengal branch and into the Arabian Sea branch. This particular portion is somewhat like this. Right. Now, here, if you take a look at the coastline of India and in general the Indian subcontinent, we know that these winds slowly and steadily are advancing over India. Even the monsoon, first of all, it hits the Kerala coastline. It takes almost 10 days for the monsoon, 7 to 10 days for the monsoon to reach up till Mumbai, the entire western coastline. It takes around 7 to 10 days. It almost takes it around a month to cover the rest of the country. By the time that it reaches Punjab, Kerala would already have been receiving rainfall for more than a month and almost month and a half. Right? So this is what is the advancing monsoon. It is advancing over the subcontinent. Right? This is your advancing monsoon. Now, this advancing monsoon is coming from which direction? Direction of the winds. Direction of winds is from where to where? Southwest to northeast. Can we say that? The direction of the wind is from southwest to northeast. Winds are oftentimes named after the direction from which they originate. So, hence, this is also what is known as southwest monsoon. That is why the advancing monsoon system, because of the direction of the winds, that is also what is known as the southwest monsoon. Is that understood? Again, advancing, explain. Advancing, why it is known as the advancing monsoon? Because you have seen that the entire low pressure system, slowly and steadily from the south, it is covering them, it is advancing towards the north. Along with that low pressure system, the winds are also slowly moving to the north. It is not going to be the case that first this area is going to receive rainfall, then Kerala is going to receive rainfall. That will never happen. First of all, the southern part of the country will receive rainfall. After around 7-10 days, the central part of the country will receive rainfall around 15-20 days later. By the time that you reach the region to the north in Punjab, it would have taken almost 1.5 months since the onset of monsoon for Punjab to receive rainfall. Is it the case that on 1st of June, every part of the country receives rain? Obviously not. So it is the phenomena is advancing over the rest of the country. That is why advancing monsoon, with the advance of the ITCZ and the low pressure systems, it brings forward the wind to cover the rest of the subcontinent, and it is in motion from southwest to northeast. That is why southwest monsoon. Is that understood? How eastern coastline is going to receive rainfall, not during the time of the advancing. Eastern coastline generally tends to receive rainfall during the time of the retreat, the northeast monsoon, and due to the cyclonic storms in Bay of Bengal. That is why. Okay. Now, the ITCZ is a zone indicating lowest pressure in the tropical region. It is in this zone that winds from both the tropics they tend to converge. The ITCZ moves to the north and south with the apparent movement of the sun, leading to the shift of the pressure belts also, isn't it? As the ITCZ shifts north and south, the pressure belts are also going to shift. As the pressure belts are going to shift, the jet stream shifts along with that. Okay, so during the monsoon months, the ITCZ passes through the region of northern India. This attracts winds all the way from the southern subtropical high pressure belt situated near Mascarene Islands. Okay, situated near Mascarene Islands. Why Mascarene high pressure winds not move towards African ITC set? What do you think? What might be the reason? Apply your logic. Is it that India is a land of opportunities that everyone wants to come to India? Is it because of some blessing that we have got from above that rainfall should occur? Simple answer is Coriolis force. If this wind tries to reach here, will it ever make it? No, this wind will get deviated to the right. That is why I will show you the satellite images, just so that if, let's suppose, the trust factor in me gets lessened, at least the satellites, they tell the truth. So observe here, it is from this zone of high pressure, winds initially moving to the left. Observe how they cross the equator. After they cross the equator, observe the movement of the winds. So here also the winds are moving. Observe the movement of the winds. Right? Why do they bend to the left? So this leftward that you see, this is because of the land influence, the coastal influence, which brings a temperature difference in these remote areas. That is why the immediate left you see. Otherwise, they generally are moving here. And then you have the, actually, what if you want to know the exact details of it, so the winds initially, other than the coastal areas where they basically get bent because of the thermal temperature, thermal difference in heating. Here, the winds, they get influenced by the Andaman Nicobar Islands, which tends to send the wind like this. Then here you have the Tanasarim, Arakan Yoma, Pegu Yoma mountain ranges. They further deviate the wind pattern. And that is why the wind appears to enter India through the region of Bangladesh and West Bengal. Okay, I hope that is understood. Right? Now, observe this area, by the way. What do you think is this? This is a kind of an anticyclone. What is this that you see on the screens, on your images? Very good. What you see on your screen is a front. So that is how many of the time the satellite images, they give you the entire story. Right? So we'll carry forward this discussion tomorrow about the subtropical westerly jet stream. Today, I urge you again, very respectfully, I urge you again, do revise the previous portions of the jet stream. Today, what we have studied, come prepared tomorrow so that it is almost a cakewalk. And then the tricellular model of circulation, try to open up the atlas and try to have that idea about where the westerlies move, where the trade winds move. I don't want an answer tomorrow if I ask that what are the wind systems at 50 degree or 60 degree. I don't want the answer to be trade winds. So do revise that portion. Otherwise, the global climate is something that you will, the Köppen's classification of climate, that is something which won't be grasped to the complete hilt. Observe where the westerlies are offshore, where the trade winds are onshore. Onshore winds will bring rainfall, offshore winds will be lacking rainfall. Come with this much amount of homework. We meet again tomorrow where we carry forward this discussion again, right? So, till that point of time, do take care of yourself. Uh, Athia, see, in that case, I think you attended the session once earlier also. So in that case, if let's suppose you have initiated the portion today itself, so I would suggest to you that just revise the tricellular model of circulation and the portion of jet streams. Do that much. can, through the gap from which Bangalore gets winds, can also lead to rainfall in southern part of India? No. You have multiple such gaps in the Western Ghats, Anjan. For example, in the region around, let's suppose, when we talk about the uh, presence of the relief features here. Now, the region, for example, the regions of Nashik, Pune, they are on the leeward side of the Western Ghats, but they receive rainfall because here you have the Thal Ghat and the Bhor Ghat gaps. Here also you have a gap which brings winds to Bangalore. Here you have the Shenkotta gap, which allows winds to come into the region around Madurai and some portion of the western Tamil Nadu. Right, you have the Palghat gap that also allows winds to come through that area. So it is the Palghat and the Shenkotta which allows the winds to bring rains in the western part of Tamil Nadu, but not in the eastern part. Okay, I hope that is understood. Right, Girish, yesterday in Bangalore, high temperature. So, as I told you, now the region in the southern part of the country will already start experiencing higher range of temperature because Bangalore typically the hottest month is when? April and early part of May. After that, it is very cool. So now the heating will begin, and the rainfall that you are experiencing today in Bangalore is a convectional rainfall. It is not any kind of other kind of rainfall, a simple convectional rainfall because of excessive heating and creation of low pressure. Lakshadweep Maldives issue is interesting one, and this basically UPSC has asked the this year also and previous year also. You remember, I don't know if you remember or not, there was a lot of debate and discussion across the many portions of the country. There was a lot of protest when the government came ahead with a plan to develop resorts and infrastructure in Lakshadweep so that it can compete with Maldives. There was series of various protests, etc., which carried on for a substantial amount of time. So that entire redevelopment program was shelved. So it is at that point of time itself when ecotourism potential of the islands that became an important topic. This time UPSC had asked that in the optional area. Maybe next year it asks again in the GS portion. But then the masala issue of it you are getting on a day-to-day basis on the news headlines. But it is always about that we have a kind of a similar resource as Maldives, similar natural resource. They both are formed out of atolls, coral atolls. Now, while Maldives ends up generating billions of dollars in revenue based upon those atolls, there's no reason why Lakshadweep should not. And that is now, at least, we should take a leaf out of them and try to develop our ecotourism potential. Okay. And what is the next day topic? Tomorrow, the question is the topic is going to be the Indian climate and the global climate. I saw a question in PTS about longitudinal difference. I didn't get how to answer it. For that, you need to have a broader idea about where all the cities of the country are situated. This will not happen by learning. Day-to-day basis, just analyze that, okay, where is, for example, Jaipur, Ranchi, Bhopal. Just have a overall idea. You will be able to solve it. Okay. Ankit, I hope that is maintained tomorrow as well. So, with that, we end the session here today. We meet again tomorrow. Take care of yourself. Goodbye. Thank you, and have a good night.